Welcome back to Gate Baba. In this lecture, we will learn how to build some height with using slip gauges. Generally, slip gauges are used for establishing a datum in industries. Datum means some height. Okay. Let's start with the slip gauge. Normal set. Normal set consists of a 45 pieces starting from 1.001 to 1.009. The total count is 9. Likewise, 1.01 to 1.09, 1.1 to 1.9, 1 to 9, 10 to 90. Okay, these are the step sizes. Okay, the step size here is 0.001. Here the step size is 0.01. Here the step size is 0.1. Here it is 1. Here it is 10. That means 1.002 plus 1.0.001. That means 1.002. Likewise, there are nine sets, 9 pieces having 0.001 step size and 9 pieces having 0.01 step size. Likewise, goes on. The total number of pieces are 45. Okay. In the special set, we have 87 pieces. Okay. Here the step sizes are similar to 0.001. Here the step 0.1. Here the step size is 0.5. Here it is 10. Why we require a special set if I have already normal set? Okay, I can build any datum. That means I can build any height with this 45 pieces. That means then why there is a necessity of choosing a special set? Okay, it will be clear with an example. Let me build up a height of 25.832 mm. Okay, so this height I want to build with a normal set. Let us start with the always there is a thumb rule for designing this. Always start from the last one. That means 0 point here. That means 1.002. Why 1 point? Because the least value of slip gauge height is 1.001 and we can't build 0.002. So that's why 1.002. Always start from the last. Always start from the decimal points. Okay, then it will be very easy to build the height. So I am choosing one piece from the set. Okay, so that means I am taking a difference of 25.832 minus 1.002 and that will give us a value of 24.83. Okay, so 24.83 menu dimension and I am taking 1.03 from it. 1.03. I am choosing a second one from it. Okay, so what is the final dimension? It will be 23.5. Is it correct? And from this I am taking 1.5. Third piece 1.5. What is the new dimension? 22.00. Okay, from this I am taking two thickness gauge. So that means it will give 20. From this I can take 20. 0. Okay, so I'm using total 5 gauges. So these are the 5 gauges I'm using. From this I'm using 1. From this I'm using the second one. From this 3. From this 4. From this 5. Okay, so total I'm using 5 slip gauges to build a height. Now come to the special set. Now you can understand what is the importance of special set. I want to build the same dimension 25.832. Always remember the thumb rule. Always come from the last. That means 1.002. Whether it is available in the special set, yes, it is available. 1.001 to 1.009. Definitely there will be 1.002. So that means I am taking one slip gauge from this set, from this first range. So now the dimension will become 24.83. Likewise here, and I am taking the second slip gauge from this range, and that will 1.33. Here the trick comes. Here we can't take more than 1.09, but here I can take more than 1.09. That means up to 1.49 I can take. If I take 1.33 from 24.83, then that will become what? 23.5. So from the next set I can delete this 1.5, okay, from this set, then that our dimension will be 20. Okay, our left dimension will be 20, so I can use only four sets of, that means I can only use four slip gauges to build the total dimension. So now come here, the total dimension will come out to be 23.5. Okay, and I am selecting a third slip gauge from this, that means 20.00. I'm selecting a slip gauge having 3.5 mm thickness. Can I select this? Yes, I can select, because the step size is 0.5 and the range is 0.5 to 9.5. Yes, definitely 3.5 will be in the range. Then I can definitely delete the 3.5 from 23.5. I will get 20. And from this, the fourth slip gauge will be 20 mm. Now our total number of slip gauges used here are 4 only. But here we are using 5 slip gauges. What will happen if I use 4 instead of 5? Or what is the disadvantage if I use 5 slip gauges instead of 4 slip gauges? Can you give me the answer? It is very easy. The basic concept, tolerance sink. We know that we can't manufacture anything to exact size. So likewise, we can't manufacture slip gauges also to exact size. There will be some tolerance on each and every slip gauge. Even for 1.001 mm slip gauge also having some tolerance like plus or minus 0.3001 mm. If I use 5 slip gauges having each and every tolerance of 0.0002 mm, those 5 will add up to give 0.0002 tolerance multiplied by 5. So the total tolerance will be higher. If I use 4 only, that means 4 times of 0.0002 mm. It is comparatively less than the normal set, because if I use normal set, what will happen? The total tolerance sink will be higher than the special set. So that's why better to use special set, better to use less number of slip gauges to build the datum. So that is the key point here. That's what I want to tell you. Always use less number of slip gauges, then only we get the accurate dimension with less tolerance sink. Okay, if I show this in the diagram, then that will be like so it is a 20 mm slip gauge, and next how much I am using, it is 2, so 2 mm slip gauge over it, it is a 2 mm slip gauge, and over that I am using 1.5 mm slip gauge, 1.5 mm slip gauge here like this, and over that I am using 1.03 mm slip gauge, so 1.03, very less, and over that I am using what, 1.002, 1.002 mm. Okay, so it is a total datum of 25.832 if I use it normal set. That means each and everything have some tolerance limits like 0.001, at least 0.00, not 1.001, 0.001. I am taking an example only. If it is having 0.001 mm of tolerance each gauge, then the total tolerance sink will add up to 5 times of 0.001, and that is somewhat relatively higher than the 1.001 mm. Okay, now come to the special set. The first one is 20, what is the thickness? Yeah, 20 mm. So it is a 20 mm slip gauge I am using, and above that I am using a 3.5 mm slip gauge right here, 3.5 mm, and over that I am using what, I am using 1.33, 1.33 mm, 1.33, and over that 1.002. So this is also equals 25.832, but the tolerance will add up to 4 times of 0.001 only. This will be the advantage of using special set. So the key point here is always use less number of slip gauges to build the datum. Okay. And the main application of slip gauges is to build datum and in angle measurement, indirect angle measurement in sine bar, and also in like interferometry, like optical flats. So many advantages. We will see this later. In the angle measurement, we will see the advantage of the slip gauges. In the interferometry, also we will see the advantage of these slip gauges. Okay. In that section, we will discuss those things. And this is it for now. Thank you.